Unit 10, Circles, Lesson 10.5, Angles, Intersecting Chords, Secants, and Tangents. Let's learn something new. Recognize and apply angle relationships formed by chords, secants, and tangents intersecting on, inside, or outside a circle. Tangent line to a circle theorem. In a plane, a line is tangent to a circle. We have a diagram down there. If and only if, to a implication, it is perpendicular to a radius drawn to the point of tangency. Yes, right angles. Gotta love it. Exterior tangent congruence theorem. If two tangents from the same exterior point, like point A, are tangent, there's our points of tangency, to a circle, then they're congruent to each other. So in circle C there, we have a tangent AD and a tangent segment AB. And since they both are coming from point A, their lengths are the same. Angles inside the circle theorem. If two secants or chords intersect inside a circle. So our diagram there is secants, but it could be chords. They just wouldn't go outside the circle. They would stop once they get to the circle. So if two secants or chords intersect inside a circle, then the measure of each angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So in our diagram there, angle 1 and angle 2 are vertical angles, so they're congruent, right? Everything from day one's fair game. So measure of angle 1 or 2 is 1/2 the sum of the intercepted arcs, which are arc AB and arc CD. Let's use it. So we need to find the measure of angle AED. AED. This time we have intersecting chords. That's the angle that we want. And we have the two intercepted arcs. So measure of angle AED is 1/2 the sum of 45 and 109. And 45 plus 109 is 154. 1/2 of that is 77 degrees. And there we have it. Here's a little side note. Okay, vertical angles are congruent. We already know that one. Side note. Because sometimes they ask for the angle that you don't have the intercepted arcs for. But if you're looking for the measure of angle AEB, remember that is a linear pair with that 77 degrees. So 180, because linear pair add up to 180 degrees, is 103 degrees. Yes, vertical angles are congruent, so they're both 103. Number 2, calculate to find each measure. Show your work, of course. Find the measure of angle STR. So we have two secants there. STR, boom. There it is. That's the one we want. And we have the intercepted arcs. And they're the ones in light blue there. So the measure of angle STR is 1/2 their sum, the 112 and the 186. And if you add 112 and 186 together, you get 298. 1/2 of that is 149 degrees. So the measure of angle STR is 149 degrees. Angles on the circle theorem. If a secant or chord and a tangent intersect at a point of tangent C, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So there's one of them, that's the left half, angle 1, gives us the arc measured. The angle, if you double it, you get the arc. If you're looking for the angle, you cut the arc measure in half, and then you have the angle measure. So you can go either way. Here's the other side. And we would need half of that intercepted arc. And it's a major arc, so it needs a 3-letter name. Find each measure, so I'll work number 3. Find the measure of angle DEG. And that's the first one we're going to be looking at. And we're looking at an angle. So if you look down at your formulas over there, to get the angle is half the intercepted arc. And we do know the intercepted arc, and it is 308. So we need to do half of 308 degrees, which is 154 degrees. Got one of them done. The other angle they need is GEF. Now look at the green question mark and the orange question mark. Those two angles form a linear pair. Linear pair are supplementary. Supplementary angles are two angles that add to 180. Everything from day one's fair game. All right, so let's find the orange angle. So the measure of angle GEF is 180 minus the 154, which is 26 degrees. There we have it, all done with number 3. Number 4, we are looking for a couple arcs that's shown in the work area, but we also need to find the measure of an angle. So the first thing they give us, really the only thing on the diagram besides the tangent and the secant, is that angle measure. So the 23 degrees is for the angle, and if we double that, we get the arc. So the arc is 46 degrees. The rest of the circle arc, M, N, L, or actually K, N, M. I wasn't going to L. That's so silly. So the rest of it, well, all the way around 360. So take away the 46 we know, and we get 314. So that arc is 314 degrees. Now the angle, MKL, now intercepts the 314 degree angles. So we can either use our linear pair idea from last time, because they form a linear pair, and get 157, or we could do half of the 314, get 157. Either way is fine. Both are legitimate and both give you the correct answer. Angles outside the circle theorem. If a tangent and a secant. So look at that. We have 3 different cases there, and that one is describing case number 2. Tangent, make sure you can see it, know what it is, and a secant. Or 2 tangents, and that's case number 3. So there's 2 tangents there meeting from a point outside the circle, or 2 secants. And our diagram off to the right is that case number 1, which has 2 secants, and they intersect outside the circle. Then the measure of the angle formed, so the blue angle, measure of angle A, we have our formula there. It's half of the difference this time of the measures of the intercepted arcs. So we have two different intercepted arcs. We have arc DE and arc BC, and we would need the difference. Of course, you're always going to go the biggest minus the smallest, and the biggest is always the one farthest away, and the smaller one's the closer one. And remember, it's still half, but it's half the difference, and that's the angle. Measure of angle A. We're finding measure of angle JLN. That angle right there. Our formula is down to the right, and we're looking for the angle, and the angle is half the difference of the two intercepted arcs. There's one, the one farther away, and there's the other one, the one closer to the angle. So the measure of angle JLN is half of 140 degrees minus 66 degrees, which is half of 74, which is 37. Measure of angle JLN is 37 degrees. Number 6, find the measure of angle ACE. ACE. This is the same case number 1. It's half the difference of the intercepted arcs, but we don't have both the intercepted arcs. But this time we do have a diameter because we have to find that other intercepted arc. And a diameter is going to give us a semicircle. And semicircle is 180 degrees. And we know two of the measures. So if we do 180 degrees minus the 67 minus the 94, we're going to get that intercepted arc, which is 19 degrees. Now we have the two arcs that we need to use. Other intercepted arc, the one farther away, the one that we're going to put first in our calculation. So measure of angle ACE is half the difference of 67 degrees minus 19 degrees. That difference is 48, and half of that's 24. Angles outside the circle. Example 7. Calculate and find each measure. Show a work, of course. Find measure of arc, SW. We do have the two secant situation going on again. There's an intercepted arc, and that's what we're looking for. We haven't done that before, but look over here, the right, upper right this time, for a formula. Measure of the angle is half the difference of the intercepted arc. So it's an equation. We're just going to plug everything in that we know, and the only thing we don't know is the measure of arc SW. So little bit of algebra that this time. Yay! Don't say boo to that. Come on. So let's see. Measure of angle SUV or TUV, same angle, is going to be half the difference of the measure of arc SW and the measure of arc TV. Now let's put all of our numbers in. The angle is 40 degrees. That was given to us. And measure of arc TV was given to us. That was 75 degrees. So we have 40 degrees equals half the difference of the measure of arc SW minus 75 degrees. To get rid of the 1/2, we multiply both sides by 2 because half of 2 is 1, and the right-hand side is no longer going to have that fraction there. And 2 times 40 is 80. So here we go. 80 degrees equals the measure of arc SW minus 75. Add 75 to both sides. Measure of arc SW is 155 degrees. Final answer, number 7. Here we go. Mastery Connect examples. So we have segment TQ and segment TR, and they're secants. And it is case number 1 again. There's one intercepted arc for our circle. There's the other intercepted arc, and we're looking for the angle. Okay, that's how the formula is set up. Measure of the angle is half the difference of the intercepted arcs, and it's the one farthest away minus the closer one. So measure of angle T is half the difference of 70 degrees and 34 degrees. So simplify 70 minus 34, you get 36. Half of 36 is 18. B is our answer. Another Mastery Connect example. This time segment PQ is tangent to the circle, and it's going to be case number 2. It looks like that. So there's our point of tangency. And there was a mistake in this problem. It should not be lengths, it should be measures, because measures are in degrees. Lengths are not in degrees. So there's a little typo there. We got that fixed now. Come on. 160 degrees is the one farther away. It's already marked. 60 degrees is there. And it's going to be looking for the measure of angle Q. All right. Measure of the angle is half the difference of the intercepted arc. So 160 degrees minus 60 degrees, which of course is 100 degrees, and half of 100 is 50. A is our final answer. Well, the end of lesson 10.5, inscribed chords, secants, and tangents is done. Thanks for stopping by.